The second descriptive statistic that we're going to look at is determining the strength of the relationship. How strong is the linear relationship between two variables? For example, these two variables, x and y, here's the regression line, the line of best fit, and you can see how far these dots are away from the line. Over here, with these two variables, we have a regression line, and the dots are very tightly grouped around the line. Typically, the tighter the dots are grouped around the regression line, the stronger the linear relationship the two variables have. So what we would like to do is measure how close the data points are to the line, and that's our measure of the strength of the relationship between two variables. To measure this, we use something known as the coefficient of correlation, which is the letter R. Now, this coefficient of correlation goes from -1 all the way to +1. Now, it gets stronger as you go away from 0. So, for example, R of -1 means that you have a very strong inverse relationship between two variables. And R of a +1 would mean that you have a very strong direct relationship. And if R is 0, it means there's no relationship between the two variables. So when we use the coefficient of correlation module in Microsoft Excel, and this gives you a correlation matrix. And what we're interested in is the intersection between the number of rooms in the home and the number of kilowatt hours of electricity. And this tells you that R is 0.9038. And that would indicate, since that's fairly close to 1, that would indicate that those two variables have a pretty strong direct relationship. A second measure of the strength between two variables is the coefficient of determination, represented by R squared. Now, what we like about the coefficient of determination is how it can be interpreted. Coefficient of determination is the percentage of the variation in the y variable that is explained by the change in the x variable. How much of our variation in the y variable is explained? Now, in the number of rooms in kilowatt hours, we had an R of 0.9038. If we square that, we get 0.8168. And we would interpret that 82% of the change in kilowatt hours of electricity can be explained by the change in the number of rooms. So 80% of our observed change in kilowatt hours can be explained by the change in the number of rooms in a house.